Students, read the question carefully. Which of the following are sets? The collection of all the months of a year beginning with the letter J. We have to decide whether this collection is a set. Let us think carefully. These months are clearly identified. There is no confusion. Therefore, this collection is well defined. Students, now observe question 1, part 2. The collection of 10 most talented writers of India. Can everyone choose the same 10 writers? No. Different people may have different opinions. Therefore, this collection is not well defined. Remember, opinions cannot form a mathematical set. Students, let us solve the next part. A team of 11 best cricket batsmen of the world. Again, different people may select different players. Therefore, this collection is not well defined. A mathematical set must always be well defined. Please pause the video and copy these notes. Students, now read the next question. The collection of all boys in your class. Can we clearly identify every boy in the class? Yes. Therefore, this collection is well defined. Please pause the video and copy this solution. Students, the last part says, the collection of all even integrals. Every even integral can be identified clearly. Therefore, this collection is well defined. Excellent. We have completed question number 1. Students, now let us solve question 2, part 1. We have 3 sets. Set A contains 0, 2, 4 and 6. The question asks whether 0 belongs to set A. Let us observe the set carefully. 0 is present inside set A. Therefore, 0 belongs to set A. We use the symbol belongs to because 0 is an element of set A. Please pause the video and copy this solution. Students, now let us solve the next part. Does the number 3 belong to set C? Observe set C carefully. Set C contains only the letters P, Q and R. The number 3 is not present. So we use the symbol does not belong to. Please pause the video and copy these notes. Students, now check whether 8 belongs to set A. Observe every element carefully. 0, 2, 6, 2, 4, 6. 8 is not present in set A. We use the symbol does not belong to. Please pause the video and copy this solution. Students, now let us solve the 5th part. Does the letter P belong to set C? Observe carefully. The letter P is one of the elements of set C. Therefore, P belongs to set C. Please pause the video and copy these notes. Students, this is the last part of question 2. Does 7 belong to set B? Observe carefully. The number 7 is present in set B. Since 7 is an element of set B, we use the symbol belongs to. Excellent. We have completed question number 2. Please pause the video and copy these notes.
Good morning, students. Now let us solve exercise 2.1, question 3, part 1. Read the statement carefully. The element x does not belong to set A. We have to express this statement using mathematical symbol. Observe carefully. The word does not belongs to represented by the symbol does not belongs to. Therefore, we write x does not belongs to A. Students, let us solve the next statement. Read it carefully. The letter D is an element of set B. The word is an element of mean belongs to. In mathematical, we represent belongs to using the symbol belongs to. Therefore, we write D belongs to B. This is correct mathematical notation. Students, now read the third statement carefully. The number 1 belongs to the set of natural numbers. We represent the set of natural numbers by the capital letter N. Since 1 is the first natural number, it belongs to the set N. Therefore, we write 1 belongs to N. This is the correct mathematical notation. Students, now let us solve the la last part of question 3. The statement says it does not belong to the set of prime numbers. Let us verify. A prime number has exactly two factors. The number 8 has the factors 1, 2, 4 and 8. Therefore, 8 is not a prime number. Hence, we write 8 does not belongs to P. Remember, always check whether the number satisfies the definition belong before writing. Students, now let us being questions 4. We have to decide whether the given statement is true or false. Read the statement carefully. 5 does not belong to the set of prime numbers. Let us verify. The number 5 has exactly two factors, 1 and 5. Therefore, 5 is prime number. This means the given statement is false. The correct statement is 5 belongs to the set of prime numbers. Students, now let us solve the second statement. Read it carefully. Set S contains the element 5, 6 and 7. We have to check whether the number 8 belongs to set S. Observe the element carefully. The number 8 is not present in the given set. Therefore, 8 does not belong to the set S. Hence, the given statement is false. Students, now let us solve the last statement of the question 4. The statement says that 8 by 11 belongs to the set of integers. Let us check. 8 by 11 is a fraction. Integers do not include fractions or decimal numbers. Therefore, 8 by 7 does not belong to a set of integers. Hence, the given statement is false. Students, now we shall learn how to convert a set from set builder form to roster form. Read the question carefully. We have to write the set of all natural numbers smaller than 6 roster form. Natural numbers begin with 1. The number lesser than 6 are 1, 2, 3, 4 and 5. Therefore, the roster form is 1, 2, 3, 4, 5 written inside the curly bracket. Students, now observe the next question carefully. We need to find all two digits natural numbers whose digits add up to 8. Let us check each number carefully. 17 because 1 plus 7 equals to 8. 26 because 2 plus 6 8. 35, 44, 53, 62, 71 and 80 all also satisfy the condition. Students, now let us solve the next question. We have to find the prime numbers that are divisors of 16. First, to write the prime factors. 60. 60 is equal to 2 into 2 into 3 into 5. Therefore, the prime divisors are 2, 3, and 5. And the roster form is 2, 3, and 5 inside curly bracket. Friends, now let us solve the fourth part of question 5. Read the question carefully. We have to write the given set in roster form. The set contains all the letters in the word BETTER. First, write every letter. We get BETTE and R. Now remember an important rule. A set contains only distinct element. Repeated elements are written only once. Therefore, the roster form is BET and R inside the curly bracket. Excellent students. We have completed question 5. Let us revise the method. First, read the given condition carefully. Next, identify every element that satisfies the condition. Then write all the elements inside curly bracket. Do not repeat any elements. Finally, verify your answer before moving to the next question. If you follow these steps carefully, you can solve every roster form question correctly. Students, now we shall learn how to convert a roster form into set builder form. Read the given set carefully. The elements are 3, 6, 9, and 12. Observe the pattern. Every number is a multiple of 3. Therefore, instead of listing all the elements, we describe their common property. We write the set as the set of all multiples of 3 that are less than or equal to 12. This is the required set builder form. Always identify the common property first. Students, now observe the next set carefully. The elements are 2, 4, 8, 16, and 32. Notice the pattern. Every number is obtained by multiple the various previous number by 2. These numbers are powers of 2. Therefore, we describe the set using this common property. The set builder form is written using powers of 2. Whenever we see a pattern like this, identify the mathematical rule before writing the answer. Students, let us solve the next question. The elements are 5, 25, 125 and 625. Observe carefully. These numbers are powers of 5. 5 is 5 raised to the power 1. 25 is 5 squared. 125 is 5 cube. 625 is 5 raised to the power 4. Therefore, we write the set builder form in the following power as 5. Students, now let us solve the last part of the question 6. Observe the numbers carefully. 1, 4, 9, 16, 25, and so on to 100. This is a perfect square. 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square, 25 is 5 square, and 100 is 10 square. Therefore, the set builder form is set to all prime numbers equal to n squared, where n is a natural number from 1 to 10.